Hello, this is Mark Tucker,
And this is Alan Furstenberg,
and we are Two Voice Devs.
Two Voice Devs. Mark, welcome back.
Thanks. It's good. It's good to be back. Sometimes chaos of life gets in the way, and but it's good to be back. So I appreciate all those who have sat next to you over the last episodes. Lots of things have happened, and lots of good things to talk about. So happy that you were able to keep things going on the podcast, and we had some great co-hosts along with you.
No, it's been fun. It's great exploring a lot of different perspectives and such, and seeing what a lot of different people are doing. But kind of speaking about what people are doing, you've been working on some new projects recently that I'm looking forward to hearing about.
Recently, probably within the last month, I was introduced by somebody, well, at least told, hey, you should check out a project called Crew AI. It's a framework written in Python to do multi-agent synchronization. And I thought, sure, that sounds pretty good. So I went to look at it, and I was trying to figure out what is the best way for me personally, how to approach it to better understand what it's doing. Documentation was okay. Python's not like my primary programming language, so there's some challenges with just like jumping in and reading code. And so I decided that I would go ahead and create a TypeScript version of Crew AI. And because you can use TypeScript with TypeScript projects or JavaScript, I decided I was going to name this port of it JCrew AI. Sounds kind of stylish, right? I have to admit there were some times where just the fact that I wanted to see something done with JCrew AI to be able to post it would just kind of kept me going. So
I can appreciate that, and it's a cool
it's
name.
really it's just really a start. It's got some of the core functionality. There's and we'll talk a little bit about how Crew AI works and some of the things that I found most interesting. But basically, I would look at the Crew AI code. I would figure out what the equivalent, and some changes. Sometimes I change things because TypeScript does things better or easier in some ways, especially like with JSON handling. But I just looked at some different things and approaches, but I tried to follow fairly closely how they were doing it, which in some cases were challenging because they would create like an agent, and then you'd pass this thing to the crew, and then the crew would pass it to the task, and just like all these, just the way that it was put together was like, well, I don't know that I would necessarily have done it that way, but it was good to learn that way because then I could get it into JavaScript code. I could get say what is the bare bones. Really wanted to get something going where I could create a couple of tasks and I could run it through LLMs and get a response back and get at least something working. So that was the goal. That's where it's at now. It's got quite a bit still to do. If you wanted to, it's not production ready by any means, but it served its purpose in helping me better understand how Crew AI worked under the covers and just kind of their approach. So that's kind of what we're going to talk about today.
Good start then. So when you say that Crew AI is a library for coordinating multiple agents, I think is how you put it. What does that mean?
Yes. So the idea is that there's two different modes of Crew AI. One is the crew mode, and that's what we're going to talk about today. There's something else called the flow mode, and we're not going to talk about that. But in crew mode, the idea is that a crew is a group of workers. Think about like you're driving down the road, and you've got people in orange vests on the side of the road, some crew working on a job. So that's what crew means in this context. So a crew is a group of agents, those are your workers, and that's also a list of tasks to do. So every task is described and has a description of it. Every agent has a description about the agent, and every task indicates which agent should be working on this task.
Okay.
What it means by multi-agent is that you really, in the end, have a list of tasks to do, and as you go through each task, then it figures out which agent should do that task, takes the information from the task, takes information from that agent, and some boilerplate, and forms a prompt. The agent knows which LLM to use, so each agent could use a different LLM, and then each LLM could use tools to accomplish their tasks. So that's kind of
Okay.
the gist of it. But
So what it sounds like is that because my next question was going to be what is an agent in crew speak, but what it sounds like is that each agent is basically kind of made up of, I don't know, a fairly specific prompt or system instructions combined with other additional information. So it's a fairly narrow thing.
yeah, so like you might have an agent that is a researcher, and their job is to research a specific topic. Now, maybe they would use a search tool to search the internet to gather information. But every agent has a role, a backstory, and a goal. So when you create an agent, there's a configuration file. It's a YAML file, and so for each of the agents in the agents.yaml file, you're going to give the agent a name. You're going to give it what their role is, what their goal is, and what their backstory is. So those things go into the system prompt when you're creating the prompt to send to the LLM with some boilerplate that basically puts them together.
Okay.
So that's kind of the role that the agent takes on. Now, the task has a description of the task to be accomplished and what the expected output is. And that actually goes into the user part of the prompt, plus some
Okay.
boilerplate as well. So what this does is it basically when you kick off a crew, a job for the crew to do, then it's going to iterate through each task. For task number one, it's going to pick out the details that it has about the task, which is the description and the expected output. It's going to find the agent that should be executing this task, grab that agent's role, goal, and backstory, and format that plus some input values and other things, and if tools are involved or not. There's just a number of things that build that up, and then it sends it off to the agent to execute the task, which sends it to the LLM, which then gets the response back.
Mm-hmm.
And let's say this is a simpler example where there are no tools involved. Then what happens is it just gives back the response, and then it moves on to the next task, but it keeps track of that response in memory, and then you can kind of chain those things together. So after all the different tasks are completed, then you'll have a final response or a final thing that happens. And that's the output of the kind of the whole multi-agent pipeline or process.
I'm sort of getting it. It's interesting. So I'm beginning to sort of get this, I think. I guess one of the questions I have is you say it takes the task, it gets a task and it gets the agent for that task. How does, well, two things, I guess. One is, what is it? And two is, how does it figure out what agent to use for a task?
Okay, good questions. So there's basically two projects that are involved with this. There is the framework project, and I'm just going to talk about Crew AI because JCrew AI works the same way. But so
Okay.
what you would do is there is a framework called Crew AI, and it's something that you would include in your project. And the project that you're creating or including it in is like a client project. It's the thing that's going to be running this, coordinating this multi-agent, collaboration.
Okay. So you're writing an application that uses the crew library.
Correct. The framework or library code includes a set of what they call slices, which are just basically translated or internationalized, whatever versions. So there's a translations folder, there's an English.json file that has all these different keys that are under slices. And so for each key value, then that's the boilerplate. So there's this portion, which is the overall prompt. It's got a placeholder for putting in where the goal and the backstory and the role in, and that fits into an overall template, and those you put those templates together. So the library itself or the framework itself has those files. Now you can override those files with your own versions of those in the client app side, but it's the client app that defines the configuration files for the agents and for the tasks. So
Okay.
basically, you'd create a brand new project, you'd reference your Crew AI, you would create your config files for your agents and your tasks, potentially your overrides for your boilerplate templates. And then in that code, you're going to create a Crew AI or like create a Crew object. And inside that Crew object, it's going to have all of your agents and all of your tasks. Now, what it does is it uses decorators, annotations, however you want to reference it. So you just decorate various functions, and inside those functions, they new up an agent object or new up a task object, and you can pass in that configuration file. So it gets newed up with that configuration information. Plus, with the agent, you can pass in what LLM it's going to use when the agent actually executes its task. So,
Okay. I find it a little bit interesting that the prompt templates are defined not in the context of an LLM. That's really interesting to me.
yeah, so there's some generic ones. And you can override those, but there's also a third, I guess, way of doing it is that when you create an agent, you can pass in overrides of those templates as well, specific to an agent, because the agent knows which LLM it's going to use. So there could very well be some
Okay.
LLM specific templating. So good call. That you have a place where a function where agent object each creation. So I guess it's a builder function that each agent has its own function, which is decorated with a agent attribute. Each task has a function that creates a task that's decorated with a task. And then there's a crew function that's decorated with the crew attribute, and it creates up a crew. Now what happens is because of how decorators work and stuff, then when the classes are, I guess before the classes are created, you can go through and in essence enumerate them so you know and new up each of one of those. And so now behind the scenes, some magic happens, and the crew knows about the list of all the agents, and it knows the list about all the tasks. So now you've got a crew object that knows about the things that are important to the system, and like the agent knows about the LLM it's going to use as well. So that's all included. So all you really have to do in the client application is do crew.kickoff, and you can pass in an object that has key value pairs, which is the input, and that can be additional placeholders. So like I can create a researcher task and say, this is the topic of my research. And then I could pass in that input array and say topic equals AI LLMs, or whatever the topic is. So there is a way to also parameterize the role, goal, backstory, expected output, and description that goes along with the agents and the tasks.
Okay. So I feel like when I'm still missing those somewhere, and I realize this is because I'm not quite seeing it.
Yeah.
When you create the crew object, you're giving it agent objects and task objects. Correct?
Yes.
But in the process of doing that, is that where you're pairing up the task object and the agent object?
Yes. Because part of the metadata that goes along with a task is which agent is used.
Got it. I think that was the piece that hadn't clicked for
Yeah.
me yet. Okay.
Yeah. And so then all that happens behind the scenes with when you say crew.kickoff is it goes through and it basically enumerates each task, finds the agent that goes with that task and then tells that agent to execute the task, passing it the task. So then now the agent does what it needs to do to build up the prompt and it sends the prompt to the LLM and then gets the response back.
Mm-hmm.
And then once that's done, then it gets the response back and then it goes and says, oh, I've got another task to accomplish. So then it kicks off, it gets the next task, finds the agent and tells that agent to execute that task, and then it responds. So basically the sample that I've got links to that we'll provide is basically two agents, two tasks. One's a research task, which is going to get back a list of 10 things. And then the second task is to format some sort of a report, including that information.
So this kind of makes sense. It seems fairly straightforward.
Yeah. And it's kind of interesting because, like, if I were to look at something like voice flow, behind the scenes, there is some prompt. In the end, when you're talking to an LLM, there's some sort of a prompt.
Right.
And this was just seemed like it's a little bit of a clever way, I guess, by splitting up the roles of agents versus tasks and putting some of that description about the agent in one place, and that agent could potentially be used against multiple tasks. And then in the task, some additional metadata that was task specific.
That's kind of where I was going with it, is thinking, okay, so you can have one agent and you're giving it, you may give it multiple tasks that accumulate information, and you've got agents along the way that are breaking it down or summarizing it or adding more information based on existing information or whatever, but you have this agent configuration reuse. And that does make a lot of sense. I think it's an interesting way to, one of the things that I feel like was missing from a lot of the core libraries that everyone provided is this notion of how do you mix predefined elements and elements that you may want to apply to just this LLM in this way and user elements. And I think this is a nice, clean way that you make that kind of description. So yes, you've got templates, but you're also saying that in this template, an agent defines these parts of it, and the task defines these different parts of it. And I think that's an interesting approach.
Yeah, and I have a diagram that basically says this is the prompt that gets passed to the LLM. This is where it pulls the parts from the config file from the client application. These are the parts that are the boilerplate template from the slices that are in the library itself. Mm-hmm. But like in the end, and I won't read the whole thing, but basically using information from the agent, it says something like, you are an AI LLM senior data researcher. So it kind of like gives it some job. And then the backstory is, you're a seasoned researcher with a knack for uncovering latest developments. So then it kind of goes on with that. And then the boilerplate says your personal goal is, and then here's the goal that you define in the agent, uncover cutting edge developments in AI LLMs. And then some more boilerplate that's like, give your best and final answer. And this would change a little bit if there was a tool or not tools, because if there's tools, it would say use these tools. And the tools are defined on the agent as well. And so it would know which tools it would need to use. And then there's like some sort of a thought that it's giving it. So it's like, give your final answer. So that's like the system portion of the prompt. And then the user portion of the prompt is getting pulled out of the task, where it says the current task is conduct a thorough research about this topic, and make sure that you find any interesting things in the current year of 2025. Now, 2025 was a placeholder value that we passed in as an input. And then it says, what are the expected criterias? And this would be like the expected output was a list of 10 bullet points. So these are things that it was pulling out of the configuration for the task in this case. And so those together then fit into a bigger, it says, now give a summary and, give the complete answer. Don't give a summary. And it, ties all that stuff together with a prompt and say.
And I think what I like about a lot of this is that some of what it's doing here is kind of it's basically saying these are best practices. We've worked on this, and these are best practices. This is stuff we've talked about for a couple of years now and said, when you're building a prompt, give it a backstory, give it an identity, give it a clear goal, do these specific things. And here's a system that is saying, not only are we going to say this is a good idea, we're going to make that easier for you. We are defining that for you. So kind of making it easier for you to do the best practice. And I love systems that just, say, we're going to make the best practice easy for you and reduce boilerplate for you. And that's what I love about some of these systems.
Yeah, I like it too. Without turning on like verbose mode or going on to, in this case, the LLM we used was OpenAI. Going into the logs of OpenAI and seeing what the actual prompt was, then you don't have to worry about exactly how you format the prompt. As long as you provide this information about the agent, as long as you provide this other information about the task, and specify any tools if you have any, then it's going to create the prompt for you.
So this is all very cool. This is interesting, very interesting work that I see you've gotten yourself involved in.
Yeah, it's been fun. One other thing code-wise that I found interesting, and I've got a very bare bones implementation, is that the agent doesn't execute the task itself. There's another class called the agent executor.
Oh, interesting. Okay.
And yeah, and what was kind of interesting about that was that there's a loop inside there, and so what it's going to do is it's initialize the output. The formatted answer is going to be initialized to null or undefined, depending in Python it was none, but it's going to be set to nothing. And in the case of if the prompt that is being sent to the LLM is a regular non-tools prompt, then you're going to get the response back, and then it's going to get formatted as an object called agent finish. So this loop goes on until it gets an agent finish. And there's also some logic in there that I don't have implemented in this particular JCrew version yet, which would have to do with max number of iterations to try. But if you had tools and there were tools involved, then what would happen is the response would come back and it would be a agent action object that gets returned. And since that's not an agent finish, then it's going to go through the loop again, doing another pass with, now you've got additional information, and maybe the next tool it will figure out what to do. And so that's kind of, that loop is kind of the brain or the core of the logic to go through all that.
What I find interesting about this is that almost every, this is a standard React loop at this point. Almost everything that is calling itself an agent library says we have this loop. About the only one that doesn't is LangGraph. And it's funny because LangGraph grew out of the React agent in LangChain. And the LangChain React agent does exactly this loop. Same thing. Keeps looping, evaluates the tools. If it's evaluated a tool, then go through the loop again. If it gets a formatted answer back, then return that answer. And the LangChain team realized this is good for simple agents. But when you want to start building more complicated agents, you need more complicated decision making. And that's why they built LangGraph. So it's interesting to me to see all of these libraries and platforms and tool sets are still working on this very, very simple loop. And LangChain built a whole other product because they saw this simple loop is great for a lot of things, but not everything. It's but it's the right starting place. And I think that's really important, is that all of these agents are really fundamentally starting from this core idea of, evaluate this loop over and over and over again. When 2 years ago now at this point, when I was talking about the fuzzy human digital computer divide, I was showing a loop. you know, it's
Yep.
it's the right it's the right pattern. At least the right pattern to start with.
Yeah, and it would be interesting to see if what they're doing in the flows portion of Crew AI is closer to what LangGraph is doing, because they're saying in some cases, you know, giving a list of tasks and say just go do these tasks is good for for some cases, but there's other cases because I think in this case it's like you have code that calls an agent, and an agent could call code or call code that calls another agent. So it seems like it's more of a scripted flow. And I'm trying to think
That's
about like
very
where
interesting.
that would be in a conversation. So you could just say do these things, and like here's a task, and it's kind of this is crew approach is kind of like a pipeline where the output of one feeds into the input of the next, and you keep going through until all the jobs are done. But I could also see some part where you want to have more of a, I don't know, like the checkout of like an order shopping cart
Yes.
checkout or something. There might be some very specific things in certain order that you want things done the same every time. You don't want these agents to go think on their own. You want, this is the conversation. This is for the more for the interaction with the user than it is for the agent to figure things out. So I'm wondering, I don't know enough about Crew AI flows to see how it might compare with LangGraph.
Like with a lot of the other agent libraries that are out there, they all have this very simple default, and I kind of wonder, okay, where are they taking it that next step? What are they including in so that you can say this will work 90% of the time, but how do I control that other 10% of the time? How do I evaluate the result and make sure that this result is safe or sane or, fits within budget or fits within business rules or any of a bunch of other criteria that we may want to make sure we evaluate as part of an agent.
What's also interesting, what I made think about is like even with the examples that was doing with Crew AI, their out of the box samples, and then the sample that I wrote with JCrew AI was it still just for two tasks still took a while. It was slower than I thought it should be, and I'm not exactly sure. I didn't investigate, but it occurs to me that this loop concept is you don't really know how long it's going to loop.
No.
How many seconds it's going to take for it to finally figure out what the answer is. And so we have to think about different patterns on how we're interacting with users during that.
And I guess that actually also takes me to one of the questions that I see come up every so often is where does the human fit in this loop? If the human is only putting the initial input in and getting the final output out, that might be okay in some cases, but in a lot of other cases, you will do some stuff and then you need to check in with the user and make sure that yes, it's actually okay to withdraw this money from your account or, delete these files or, other things that an agent might do. Sometimes you want that human in the loop. And how does it take that into account?
Yeah, I didn't pursue the part of the documentation that talked about that, but it did seem like there was one ability to do prompts where at a certain point it would ask the user before going on, so it would be a person in the middle approach. And there were also a part of the output that I didn't really look at either, where you could say, I want the output to be in Markdown or I want the output to be in JSON. And so then it would take the output from one step, convert it into a specific format if that's what it needed. One of the samples I looked at even had, as part of the expected output, that it was going to create, so it actually saved the report file into the folder of the project that it ran. So it seems like there are some additional pre-processing, post-processing, whether it be on the input or output side, that could happen to solve some of those same issues. But good question.
And that makes a lot of sense. Is making sure that if part of what this toolkit is doing is making sure that stuff is in the right format as part of that chain. That's important.
Yeah.
That makes a lot of sense.
Overall, this has just been a fun process, actually, to dig into code from one code base in one language and create code, in a different one, and really require me to like get to the core. Is like, okay, this class might have 20 functions in it, but these three are really the core that you have to do. Because I was trying to get the simplest end-to-end use case that actually called the LLM and got the output and went through each of the tasks and stuff. So, but it just I don't know. It was kind of an interesting approach. I don't always do it, but in this case, it was a good learning exercise to really understand behind the scenes how it's working in a way that I wouldn't have been able to if I didn't try to recode it in a different language.
No, I definitely agree. That's one of the great things about getting involved in projects like this is you get to see how the parallel project did something and how do you learn from it and mirror it but also put the right local spin on it. You're not trying to copy it, you're trying
Yeah.
to be inspired by it. So yeah, no, it's a fun challenge, and it's the sort of thing where you learn a lot. And I have to admit, I'm enjoying watching your learning process on this. You're posting it on LinkedIn as you're going, so
Yeah.
that is it's fun to read those snippets.
Yeah, so I'm going to continue to share some of the stuff, and right now it's in a stage where it's great for learning. If somebody wants to take it on and do more with it, I'm open to that as well. And it's one of those things that I purposely didn't look to see if there was another TypeScript library that was based on Crew AI because I didn't want to know how they did it. I wanted to go in there fresh. Turns out there's a couple of different ones that seem like didn't take quite the class by class approach that I did, but in the end, like has the same functionality or feel for it. Haven't really looked at them too deeply, but there are other places to look that might help you understand just how AI works and interactions with LLMs, and at least one person's approach to how that all fits together.
So, an exciting project. Uh, Looking forward to seeing how it develops. Folks, feel free to reach out, comment below, or comment on your posts on LinkedIn, and I'm sure we'll be talking about this some more on Two Voice Devs.
Two voice devs. Take care, Alan.
Take care, Mark.